Hello everybody, this is Red Eagle here. Gonna make you a little video. Actually, it's for a particular customer and anybody else that's interested, of course. But it's on the 1969 transistors used in CB radios as finals. It's the final transistor in the output stage of the radio, and basically it's what creates or amplifies your watts being produced by the radio and sent out to the antenna. Okay, there have been some questions and some concerns about replacements that are available for the 1969 final now, because the original Mitsubishi, and you can see the little Mitsubishi logo right there, the original Mitsubishi 2SC 1969 is no longer being produced. Hasn't been for quite a few years now. So when they stopped producing those, that created a real uproar in the CB community, because there were no finals available to replace the bad ones in your radio. Well, a couple of things have came along since that. One of which is the Mosfet transistor, like the Mosfet IRF 520, the 2030. They are a Mosfet also, and they work pretty good in radios as long as they're installed right. It takes a little bit of work and a little bit of circuitry modification to make them work correctly, but they do work. They do a good job. A lot of folks don't like them. Well, I say a lot. Some folks don't like them because they say that they're more susceptible to a higher SWR. They're not as forgiving as the original 1969, and that may very well be true. I don't know, because I've never had that issue. But people say that if your SWR is a little bit higher than it should be, that the Mosfet finals won't tolerate it. They blow. But again, like I said, I've not had that issue, so I can't really talk about that a whole lot. But that's one option to replace your 1969 final in a radio. They can be added. A lot of people put them in Cobra 29 LTD Classics, claim they get 50 watts out of them, which I personally don't agree with. I don't believe it, because I've not seen it. I can do it and get 30 watts of swing out of one of them pretty easy, but 50, 55, no, haven't had that happen on my bench yet. May just be because I don't know how. Could be the problem. I don't know. But anyway, I do install them in radios. I do get them to work. I get them to work quite well. They appear to be durable to me, and I don't have a problem with them. The other option to replace your original Mitsubishi 1969 is one of these little guys. And I know you can't see it right there, but what it is, let me see if I can pick this up without making a real mess out of everything. Get it to focus here. Turn it this way. And it don't look like, there it is, H2SC 1969. That is a brand new one that I purchased along with others from a company called ICA Manufacturing. I hope they don't mind me mentioning their name. I can't really imagine why they would. But I had a customer. Well, let me back up. I do replace the original 1969 with the new HG 1969, and they work fantastic. They're flawless. They work just like they're supposed to. They do what they're supposed to do. They are a direct drop-in replacement for the original 1969. If your radio has a 1969 in it from the factory, then all you need to do is take it out of the radio, put this new one right back in it, solder it in, and that's it. No modifications, no adjustments, no nothing. They are a direct drop-in replacement. Now, I had a customer contact me asking questions about it, and his concern was that someone had expressed concern to him that the HG1969 did not like linear power supplies. Now, I've tried these things on practically every kind of power supply that you can think of, really. Linear power supply, switching power supply, in automotive applications where it goes in a mobile radio and it's installed into a car, truck, SUV, whatever. But the complaint was that they pick up stray noise from the power supply. I don't necessarily know what kind of noise they were talking about, but said that the HG1969s did not like linear power supplies. They pick up noise from them. Okay. With that being said, I'm going to move these aside for just a moment, set them over here out of the way, and we're going to flip this over right here. This is the data sheet for the original Mitsubishi 1969 final. It's a silicon NPN epitaxial planar type transistor designed for RF power amplifiers on HF band mobile radio applications, blah 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 blah. You come right on down here to the features, and this is where it gives us our specs at. Speaking of, let me find something to point with here. The high power gain, 12 dB, and that's at 12 volts. This transistor, the HG, and this is the new one, because here's the Mitsubishi. We'll remove it. This transistor has a 12 dB gain at 12 volts and produces 16 watts, 27 megahertz. Okay? And you can see the other information here. Emitter, blah 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 blah, so on and so forth. TO220 package. And then down here it says ability to withstand infinite load VSWR when operated at 16 volts. It produces 20 watts on 27 megahertz. And then if you come on down just a little bit further, application, it produces 10 to 14 watts output power, Class AB amplifiers, applications, and HF band. So basically, what this is saying is that you can expect to see 10 to 14 watts out of it running it on 12 volts. Now, that is the data sheet, as much of the data sheet as I can get on the new HG 1969. Let's move it out of the way, set it off to the side, and we're going to remove this sheet of paper, which is for the original, and that brings us to this one, which is transistors HG2SC 1969. Okay, let's go right back up here, get all this back in here. HG 1969 is a silicon NPN epitaxial planar type transistor. I think I heard that somewhere just a minute ago. Designed for RF power amplifiers on HF band mobile radio applications, including CB radios on 27 megahertz. Okay, right there, CB radios on 27 megahertz. All right, move right on down here. Now, your power gain, 12 dB at 12 volt. Let's look back here. My goodness, look at that. 12 dB at 12 volt. Okay. So then we've got 16 watt, 27 megahertz here. Let's look here. Oh, look at that. 16 watt, 27 megahertz. Huh. Alright, let's move on down a little bit. See what else we can find. Ability to withstand infinite VSWR load when operated at. That's the original. I mean, the HG, I'm sorry. This is the original. Let's see, where was it at? Ability to withstand infinite load VSWR when operated at 16 volt, 20 watt, 27 megahertz. 16 volt, 20 watts, 27 megahertz. Huh. Alright, let's let me get this paper situated where you guys can see. Now, application 10 to 14 watt output power class AB amplifier application in HF band. The original 10 to 14 watt output power class AB amplifier application in HF band. You know, if I didn't know better, I would say that these two data sheets were made to identify the very same transistor. Now, here's the thing, guys. I don't really call anybody out, you know, for misinformation or simply not knowing or whatever. But these guys out here that tell their customer whatever they want to at that particular time to get the heat off their back, I'm sorry, but it's dishonest, and it's just flat out wrong. If you don't do quality work, then you have to find little tales like this to put out there to cover your back. If you do quality work, then there shouldn't be any problems come up that you would have to make up lies for to cover your back on. I don't know anything about any of these people that were asking these questions or that were spewing this misinformation. But the point is, there's nothing in this transistor that's going to pick up noise or interference from any kind of power supply that this one will not pick up. I just showed you the paperwork on both of them. You can rewind the video, you can watch it for yourself, you can look at it as many times as it takes for you to see it. They are the same inside. The company that makes this new HG one was not new. I mean, in other words, it's not something they just started producing last week. They've been around for a while. But the company that makes these, the HG, they made it to do the same exact job in the same exact way as the original Mitsubishi. There's no difference in the two. They're same package, same size, direct replacement drop-in, direct drop-in replacement, whichever way you want to phrase it, doesn't matter. The bottom line is they are the same transistor. This one was made 30 years ago. This one was probably made 6 months ago. But they're the same transistor. They do the same job. They do the same job the same way. There's no difference in them that I can find. Now, I will be man enough to say that if you can provide paperwork from either one of the companies that will prove in black and white on paper that there's a significant difference between these two, I'm open-minded enough that I'll read it and I'll say, hey, look, the paperwork says it must be true, because that's what I'm going on right here, is the paperwork for each one of these transistors. And that's all I've got to go on, besides the fact that I install these and I have never had any problem whatsoever. This transistor does not pick up noise or interference from a power supply any more than this one does. Now, the radio in question that was picking up this interference, I was told that the owner of it said that he had multiple radios and he tried them all on that power supply, and that it was only one radio that was picking up that interference, and it happened to have the HG1969 installed in it as a replacement for the original, because the original went bad. None of his other radios picked up that interference. None of his other radios had the HG transistor in them. So naturally, someone, apparently, I'm guessing someone who installed the HG in his radio, told him that the HG transistor did not like linear power supplies, and that's why it was picking up the interference from the power supply. No, that radio had capacitor problems, plain and simple. It needed some caps replaced in it. That's where the interference was coming from, was from bad capacitors. And I didn't even see the radio. I've never seen the radio. The radio doesn't even live in the same state that I do. But, you know, it doesn't take a whole lot to figure out, hey, if the transistors are the same, that's not where your problem is. The problem is bad capacitors. So anyway, I don't want to step on anybody's toes. I don't want to cause any problems with anybody, but I do want people out there to get true and correct information about what's being put in their radio and about what they're being told about their radio. A lot of these CB shops out there will tell you whatever they think you need to hear to get you off their back, because hey, they're the expert. They know what they're doing. So if their tech told them this, then it must undoubtedly be right. But anyway, I thank you very much for your time. I hope this helps some, and hope I don't offend anybody. I'm just trying to tell the truth as much as I know it. You guys have a great day. Be the old Red Eagle. We out of here.